All right, let's dive right into one of the biggest threats out there, one that's behind some of the most massive data breaches we've ever seen. But here's the thing, it's not some super complex Hollywood-style hack. It's security misconfiguration. This is that silent vulnerability, the one lurking in the background of your applications. And today, we're going to show you exactly how to find it and, more importantly, how to fix it. So let me kick things off with a question for you. When you picture a huge data breach, what's the first thing that pops into your head? Probably some shadowy hacker group, right? Deploying some kind of wild zero-day exploit they just cooked up. And yeah, that makes for a great movie plot, but the reality? It's often way less dramatic, and honestly, way more preventable. Because the number one cause isn't some elite hacker. It's a simple mistake. Yep, that's it. A developer leaving a default password in place, an admin who just forgets to apply a critical patch, or a cloud setting that was never, ever double-checked. These are the tiny little oversights that create absolutely massive security holes, and that's exactly what we're going to unpack today. All right, so let's get into the nitty-gritty. What exactly is a security misconfiguration? Well, imagine your whole API infrastructure is like a giant skyscraper. A misconfiguration is like finding out the entire foundation was built with the wrong stuff. I mean, it might look perfectly fine from the outside, but it's fundamentally unstable. It's a disaster just waiting to happen. So the formal definition is basically this. Security misconfiguration is the failure to properly lock down security settings anywhere in your API's tech stack. And I really want to emphasize that this isn't just about your code. Nope. It covers literally everything, from your network firewalls, your cloud permissions, all the way up to the application framework itself. It's such a broad vulnerability because, well, the attack surface is just huge. And this thing can pop up in so many different ways. I mean, think about it. Leaving debug mode on in a live application, that's like leaving the architectural blueprints for the whole building lying on the front lawn. Forgetting to apply a security patch, that's basically leaving a window wide open on the ground floor. And using a default password, come on, that's like leaving the key right under the doormat. Every single one of these common mistakes is a wide open invitation for an attacker. So where do these cracks actually show up? A modern API isn't just one single thing, right? It's a super complex system of all these interconnected layers. And a misconfiguration can be hiding in pretty much any one of them. And these failures can happen at every single layer of your stack. Down at the very bottom, on the network, a port that's open when it doesn't need to be can give an attacker a way right in. In your cloud setup, a misconfigured S3 bucket could accidentally expose all of your customer data to the entire internet. Even something as simple as your API's error messages can be a huge problem, leaking technical details that help an attacker literally map out your internal systems. Trust me, attackers are looking for these weak points everywhere. And don't for a second think this is a rare thing. Security researchers consistently find that over 70%, that's 70%, of all cloud data breaches trace back to a simple misconfiguration. Just let that sink in for a moment. This isn't some niche issue. It is the number one reason companies get breached in the cloud, period. Now, to really understand the gravity of these small mistakes, we've got to look at some real-world examples. I'm talking about cases where these tiny, seemingly minor cracks led to a complete and total structural collapse. Let's start with the infamous Equifax breach. The most shocking part of this whole timeline isn't just that they failed to patch their software, it's that they had months to do it. A patch for a critical vulnerability was released in March. Equifax was notified. But because their internal security processes were just broken, they never applied it. Fast forward 2 months, attackers exploited that exact vulnerability and just walked away with the personal data of nearly 150 million people. The Capital One breach is just a perfect example of how one small mistake can cascade into an absolute catastrophe. It all started with a misconfigured web application firewall. That one little crack gave an attacker a foothold. From there, they found the real jackpot, a cloud access role with way too many permissions. That single role was literally the key that unlocked dozens of data buckets, leading to the theft of over 100 million customer records. It was a chain reaction, all kicked off by one tiny misconfiguration. And of course, we have to talk about log4shell. This was the ultimate example of a dangerous default setting. You had this powerful but kind of risky feature that was just turned on by default in a logging tool that was being used by literally millions of applications. The second it was discovered, it became one of the most severe vulnerabilities ever seen, all because of one insecure default configuration. Okay. Enough of the disasters. It's really easy to feel overwhelmed by all this. But the good news, and there is good news, is that these issues are entirely preventable. So let's pivot to the solution. Let's talk about the blueprint for building a secure foundation, a real fortress.
So how do we stop this from happening? The key is to stop relying on manual checklists and, let's be honest, flaky human memory. You need a systematic, automated process. It all starts by defining a gold standard for your configurations. That's your security baseline. Then you automate the creation of your infrastructure using code. And finally, you'll build automated checks right into your deployment pipeline that will block any change that doesn't meet your security standard. It's all about making the secure way the easy way. Now, this is a perfect example of a common misconfiguration at the application level: error handling. The error message you see on the left, that is an absolute goldmine for an attacker. It's revealing database table names, internal code paths, the exact software you're running, everything. The secure version on the right gives the user nothing but a simple tracking ID. That ID is all your developers need to find the full error details in your private logs, while keeping the attacker completely in the dark. Think of this as your essential pre-flight checklist. Before anything goes live, just run through these questions. Is debug mode off? Is strong encryption enforced everywhere? Are your cloud roles locked down to only the permissions they absolutely need and nothing more? Getting these fundamentals right closes the vast majority of doors that attackers are constantly trying to open. So in the end, what we've seen is that security misconfiguration isn't really a technology problem at all. It's a process problem. It's about discipline. It's about building security into every single step. The biggest threats to your APIs might not be those flashy, brand new zero-day attacks. They might just be the simple, foundational mistakes that have been overlooked for months. So the question I want to leave you with is this: if your API stack is a house of cards, how many of those cards are already bent? Go find them.